Okay, in this session, we will study the storage device called register. So this register is the example of sequential logic circuit. So far, we have looked into two examples, that is counter and flip-flop. So you know that flip-flop is the building block of sequential circuit. Now, in the counter, you use the flip-flop circuit to construct the counter, and also you are going to use flip-flop circuit to construct the register. So register is the sequential logic circuit where it will act as a storage device. Now you might be wondering when I say register. So if you open the computer and see, then you will see the computer chips. So within the chips there will be lot of register. So therefore register will be act as a storage device. Now, in order to understand the register, so these are the key terms that you need to understand. So, register is one or more flip-flop that used to store and shift data. Stage is one storage element in the register. Shift, so in order to move the binary data from stage to stage within the shift register or other storage device, or move binary data into or out of the device. So load. So to enter the data in shift register. Bidirectional. So this is the shift register where it will have both direction. It will shift towards right as well as left. So that type of shift register is known as bidirectional. Now, so shift register, they are type of sequential logic circuit, mainly for the storage of digital data. They are group of flip-flop connected in the chain so that the output of one flip-flop become the input of next flip-flop. Now, flip-flop is driven by the clock, that is common clock, and all are set or reset simultaneously. Now, in the flip-flop, we are going to study different type of shift register in shift register. So we have serial in, serial out, serial in, parallel out, serial in, serial out, parallel in, parallel out, and we have bidirectional shift register. Now, that all the type of the shift register is depending on how you give the data and how you take out the data. Now, for example, if you give your input data in serial and if you take out your output data in serial, that is known as serial in, serial out. Now, similarly, serial in, parallel out. So your data is given in serial and output is taken in parallel. So based on how you give your data in the input side and how you take out the data in the output side, you have a type of shift register. Now, shift register, the binary information in the register can be moved from one stage to another stage within the register or into or out of the register upon application of clock pulse. With the help of clock pulse, the data input will be shifted towards right or left. Now, this is the basic shift operation. So it is shifting from right, data in is here, so data out. So this is shifting in the left, data in, data out. So again, this is right, data in, data out. So let's look at, we have 5 type of shift register, serial in, serial out. So in this session, we will focus on serial in, serial out, and we will focus other 4 type in the next session. Now, this is the block diagram of shift register, where you have many flip-flop, 1, 2, 3, 4. So you have 4 flip-flop. So you have serial in data and serial out data. Now, first, serial in, serial out shift register. Now, this is the circuit diagram of serial in, serial out, where you have 4 flip-flop, that is 4-bit serial in, serial out shift register. So your data input, it says serial in, so that should be in the serial, and data output should be in serial. So you are trying to give the 4-bit binary number, that is 1111, to the register, and the data will be shifted starting from the most significant bit. So therefore it will start from here. This is most significant bit and this is least significant bit. Now initially the register will be clear. So register will be clear when you give this clock input towards the ground, then it will clear the all output. So therefore QA, QB, QC and QD will be 0. So it is shown out here. QA, QB, QC, QD will be 0. Now you are bringing this data out here. So when you give fast clock, then your output will be QA output will be 1. So this will be 0, 0, 0. Still you have output 0. But logically and technically we know that we have output 1 at QA because we know the concept of serial in, serial out. Now when you give second clock, the output which is at QA will be shifted to QB. Then the most significant bit, so this one is already shifted, so we have third one, this one will be act as most significant bit, so it will be at QA. Now when you give clock 3, third clock, then output of QB will reach to QC, output of QA will shift it to QB, and the most significant bit at the input side, that is second one, this will reach at QA. Now when you give again fourth clock, then that output at QC will shift it to QD, similarly QB to QC and QA to QB, and you have one bit at the input side because all those three is already shifted. So therefore, QA, QB, QC, QD will be 111. So output will be 111. Only at fourth clock you have output 1. So if you give fifth clock, then you have 0 at the input side. So therefore, this 0 will be shifted over here. Output of QA will be shifted to B, B to C, and C to D. So therefore, you will have 0, 1, 1, 1. So it will be 0, 1, 1, 1. So if you look here, this is how the illustration of data entry. Your data will be shifted out here. When you give first clock, second clock, this will go to here. Third clock now, this will go to here. Fourth clock now, this will go to here. Fifth clock now, this will go to here. This is how the data is shifting. Now, this is the explanation of serial in, serial out. So there is a mistake on A, B, C, D. This should be A, B, C, D. Now CP is a clock, and at the initial stage you are cleared by giving CP equal to 0. So therefore your output will be 0, all 0. Now you are bringing your data input 1, so the most significant bit will be shifted over here. Still your 3 output will be 0. So similarly at the second clock, this will be shifted over here. So again, one significant bit will be, most significant bit will be shifted here. At third clock, this will be shifted over here, this will be shifted over here, and your most significant bit will be shifted over here. At the fourth clock, this will be shifted over D out, this will be to DC, and this will be to DB, and most significant bit to D1. So that is how the serial in, serial out shift register data is being shifted.